This is a beautiful vintage Pioneer SX-737 receiver. It's really a beauty, and it works great now. This is the happy ending of this story. I spent a lot of time on this receiver trying to find this intermittent glitch in the protect circuit. The relay kept tripping, and as time went on, it just became more and more random. And something that seemed like it'd be simple enough, well, in the end, once I know what it was pretty simple, but getting there is not always straightforward. So I bought a number of rebuild kits from a gentleman on eBay, Affinity for Artifacts, and they were great. So I replaced a bunch of components. I don't want to say randomly, but replace these doodads in the amplifier board. You know, some of these transistors are bad and they do need to be replaced. I didn't find terrible capacitors, but they are 50 years old. I replaced the components, or a lot of components, on the protect board. We'll get more into that as the video proceeds. And then we have a complete recap of the power supply board. And once again, they're 50-year-old caps, but there weren't any that were horrible, but they were showing their age. So I think we did a pretty extensive rebuild trying to track down this problem. The original edit of this video was about 9 hours long, certainly something long enough to be on C-SPAN. And but I chopped it all down. It was just too much soldering and unsoldering and probing. Chopped it down into the Reader's Digest version for you. And I did want to show you one last thing. This may look like a harmless NPN transistor, but in fact, that is the smoking gun. And I don't know if we could even say that anymore, but enjoy this video. It's cut down into about an hour. I think you'll enjoy it. And yeah, thanks for watching. We'll see you at the end. Seems to be okay.
Or like, you know, you take time to be a kid. Yeah. Right? Because you dedicate every.
There it is. It just happened.
And there's so much that you can.
That was almost a minute into turning it on.
You know, so there's ways to do it. Like I told the kids, I'm like, this other.
All right, so we haven't quite fixed the problem.
Like, you know, we're going to be doing craft.
I think we need to go back into that protection board
and be out and doing stuff and hiking and
see what we can do. Wow. It just happened again. What the hey is wrong with this? We've replaced all the transistors and all of the capacitors on this board. And we didn't do so bad. It's in pretty good shape. So we're just going to throw some juice to it and see if we still have sports talk radio.
To win Finals MVP,
yes.
He just can't have the ring on his finger from winning the NBA championship.
The ring.
He has to be
Kiss
at the
the ring
for the Boston Celtics. But there's also I'm also a realist. I do know there's a chance that Jaylen Brown could be the guy.
I mean,
But
I wonder how long this is going to work.
I want Jason Tatum to be at the forefront of it all. That's what I want to see in order for all the NBA analysts, myself, you, to put him in a.
Well, there isn't much.
We feel like his elite.
Well, it works.
He's been first team all NBA.
And there isn't much we can do about anything else on this board, so I'm going to turn it off, pull the plug, and remount it. And the real test, I guess, is maybe let it come back in a couple hours and turn it on and see if we have this problem with the protection relay activating again. But I do want to say I did find a couple of the gain on this one is considerably more than the gain of the one that was in there. Oh, it just did it again on us. Damn it. Damn it.
Yeah, because no other body wash.
It just pops and then it comes back. So what was I doing? I mean, I was handling this board.
If only there was a mountain range separating the Indian subcontinent from the Tibetan plateau where I could hide my old spice and keep my family from stealing it, my impossibly smooth skin will finally be set.
So, okay, we didn't find the problem. We still haven't found the problem. I'm totally out of ideas at this point. I was going to say that the gain on a couple of these transistors was considerably less than what the new ones are, but I guess what we just learned is that that doesn't make any difference. So I don't know, I'll revisit the idle current and the DC offset on this amplifier board.
With an ESPN Wilmington Local Sports Update, I'm Wolf Golke.
I don't know.
Local Sports Update powered by ESPN Bet. Mobile Sports.
I'm going to shut her down for a while and try back in an hour or two and see if it does it again. We'll get it all on camera. On the Protect circuit, this particular transistor, which we did change out, is the driver transistor that drives the relay coil. You can see the wires coming off. Pin 9 and 10 go right to the coil there. What they're recommending, that is Pioneer, and they did it on subsequent versions and on into other models. It's a pretty standard thing, but they recommend putting a diode across here with the cathode on pin 10, and that is intended to protect this transistor, so that when this relay switches off into protect mode, it sends the collapsing magnetic field of that coil sends quite a back spike of voltage into this capacitor. And I mean, I guess it worked fine. This is a newer, I call that a capacitor. That's a transistor. So that it worked fine before. The transistor that I took out had a lower gain to it, but it was still a transistor. But we're going to put that mod in here. I absolutely am sure it's going to have nothing to do with fixing this intermittent protect problem. But we're going to do it. I'll show you schematically what it is. So here's the schematic for this protect, well, part of the protect circuit. But this is the relay, and this is that driver transistor we were just looking at. And it's just recommended that you put this diode between pin 10 and pin 9, which is just directly across the coil. Now, we're going to put the cathode of a diode here and the anode on this side. That's what we're going to do. It's nothing more than an ordinary everyday 1N4004 across those pins. And then we move on. We're gonna start lifting some things out of the board and find out if, well, first of all, we'll get into that. Let's do this first. Well, we've got that diode mod in, but that's not going to fix our current intermittent problem. So I wanted to do a little test over here and monitor the DC volts off of the amplifier. So these two lines come directly off of the amplifier. So these are basically the speaker outputs on the right channel and the left channel. So the left is brown, the right channel is white. Comes off of the amplifier board, comes around here, it goes directly to this these two pins, pin 1 and 3, and then from pin 1 and 3 it comes off again, it splits off and goes directly to it's hard to see, but the terminals that are part of the normally open terminals on this relay. And then from the wiper of the relay it goes to the speaker select switch, and then based on how that's selected, comes back here and goes to the speaker output. So this is effectively where we measure the DC offset when we do that adjustment. You're really looking at this pin and this pin on the other side. So let's start by putting I have two different voltmeters in milliamp mode and millivolt mode, and we're going to clip on to these speaker terminals. And let's just monitor and see when we turn it on if the DC volts on the outputs gets to a point where it would logically trip this protection relay. I don't think it will, but we're going to find out. So I'm going to clip in. Got 2 meters. They're both sitting idle unconnected right now. I have no idea why one is reading -6 millivolts and one is reading what it should be. Whatever, that's fine. Close enough. So let me clip this in and I'll show you, and then we'll turn it on and we'll see how long it goes before the relay engages and before it trips then. All right, so we have the outputs. The output of the amplifier board goes to this point, speaker output essentially. The white wire, which is the right channel, goes to the white test lead, and the brown lead, the left channel, goes to the yellow. And we've got it tied into these 2 probes and into these 2 meters. So left channel, right channel. Grounded to chassis. So let's flip it on and let's see how long it takes for the relay to engage. And let's see, you'll hear AM radio when it engages. So it should be 2 seconds or so, maybe 2.5 seconds. But you'll see when it starts up that the amplifier is just not stable. I think that's pretty typical with amplifiers. It just takes a few seconds for it to stabilize, more than a few seconds maybe. So I'm wondering, a little bit down the road, is if we get in and start to modify the time delay on how long it takes for that relay to click in. That might help stabilize this a little bit more, but shouldn't have to be that way. Let's turn it on. 1001. 1002.
Second.
There we go.
When he's in the paint or wherever he ends up, he can kick it out for a 3. That's the late kick out as well as anybody.
So we're down into millivolts.
Himself, but then
this is not excessive DC voltage coming off the speakers.
Basically human pogo sticks, and that's where they're really dangerous. And those two guys have been incredible.
Usually takes about a minute or so before it
Porzingis in there. He's 7'2",
protects.
or 7'3", 7'4", depending where you look, and then his wingspan is even longer than that. And he can be disruptive in the paint. So defensively, I think his impact is even more important in this series. But obviously, you know, if he's going to score 20 points in 20 minutes off the bench, that makes a huge difference offensively.
Drew Carter with us, NBC Sports Boston.
Once again, all we need is a camera rolling all the time, and it'll work just fine.
Ready for Game 2. Everybody's saying Kyrie needs to be better. Drew, what was Boston's reaction to Kyrie sort of taking a shot at the environment and saying he thought the fans were going to be louder in Game 1 than they were?
I'm going to turn the sports talk down. Well, what did we do? Well, we put a diode across the terminals of the protect relay. It doesn't make sense that would do anything. So what we're going to do, we've been in this for about 2 minutes now. We do not have an equal balance on our DC offset. I guess we could get in there and adjust that.
To me, it's been a little bit overhyped, the backcourt of Luka and Kyrie, you know, everyone on TNT.
But I have to flip it over to get to those pots.
I feel like we maybe jumped the shark with that a little bit. Kyrie has been pretty inconsistent. If you look at that OKC,
let's turn it off. I'm going to let it, I'm going to turn it off. And I'm going to unplug it. It takes about 5 minutes for this to discharge, for capacitors to discharge before this problem would repeat itself. So I am not going to say this is the solution because I know it isn't. But let's wait a little bit and we'll try this again. Goodness gracious, when you have a complete service manual, the information that's in it is fantastic. So you really do, if you're going to get into some of this stuff, you really have to have the correct and complete service information for this. And so with this new service information, I really understood the board more so. And so these 2 points, let me go up here. Over here, pin 6, pin 5, pin 7, pin 8 goes into this these 2 detect circuits. And so if we go to that point, 5 and 6 goes into the power amplifier pins 2 and 1 and 2, I guess. And if we go to the power amplifier schematic, so these current sensing circuits come around here and they work as separate channels, left and right. And these are our output pairs, our output devices. And the 2 pins that they go to, each individual channel goes to the emitters. So this is a pair, push-pull. This is a pair, push-pull. And that monitors the current out of the output devices. And I'm wondering if, I don't want to just start shotgunning parts. I changed enough parts to no avail. And these output devices seem to be fine. This amplifier sounds really great when it's working. It just has this intermittent protect problem at startup. So once this the capacitor is discharged on the receiver, we'll plug it back in and see if it works. If the protect relay trips again at startup. But one thing to check is to start taking things out of the circuit. I doubt very much these 247K resistors are off value. These are brand new capacitors. These are brand new transistors. And this problem has been around for a while now, so I don't think it's related to this protect board. This is D5. If we lift D5 out of the circuit, that would bypass the current sensing. And that would tell us something. If we lift this and we don't have that intermittent trip, then it goes back. While I was working out in the front yard, it works fine. It works great. Driving it with some 8 tracks from my past. Yep. And putting it into these advents. Working on the wood, cleaning it up a little bit while I cultivated the soil. So I don't know what to think. This modification we did to the protect circuit, this diode mod, seems to have solved this intermittent problem with the protect circuit. And the reason why I was so hesitant to believe that that would do anything is because I had clipped it in with some leads, some clip leads, that diode, and it didn't really make any difference. So I just figured it was one of those things you do just to prevent something else from happening later on. But this thing starts up and works perfectly. I mean, I'm not going to mess with anything. Okay, so the relay just engaged, and it's going to keep working fine. I do want to say, in all seriousness, for those that have never actually listened to 8-track tapes, 8-tracks have gotten a bad rap over the years, but it's a completely different listening experience when you listen to an 8-track tape. It's just about, it just plays over and over and over again. You can switch tracks, different sections of the music. It was very clever at the time. And if you maintain the tapes, generally speaking, you have to replace the pads because they get deteriorated. But 8-tracks are awesome. It's kind of fun. Listening to music is sort of something you do. It's an event or an exercise. And you discover things. You can buy tapes like this for 50 cents or $1 somewhere in an antique store. And even like this, I'd never really listened to Neil Diamond. My mom didn't listen to Neil Diamond, but boy, when you start listening to some of this Neil Diamond stuff, you can't believe how many fantastic songs that Neil Diamond wrote that other performers did. I'm just saying, if you've never experienced the 8-track tape, you ought to give it a try. It's just not the same thing. It isn't Spotify, it isn't Apple Music, they're 8 tracks. And they're fun. And fixing them is part of the fun too. Well, I was playing some music yesterday, working in the yard, and I thought I had solved this problem of the protection board acting up, but I hadn't. So I tried another thing. This was yesterday. Looking here at the circuit, I lifted this diode that, in my mind's eye, would be the one that would disable the current sensing part of the circuit. I lifted this diode from the board, this one, and I thought that was going to give me some clues, but in fact, then a little bit later on, it was running and it acted up again. So I put it back in the circuit. And I had one last thing I wanted to try. Well, I guess I had a couple things I could have tried. Lifting this diode and these two would, I think, completely, this one, would completely disable the protection of anything in this circuit. And since I don't believe that there's anything wrong with this amp, I was thinking, who cares, you know? But tried one more thing, and that is this capacitor. Now this capacitor is the time delay cap. It's right there. It's hard to read. It's 100 at 16 volts, 100 microfarads. And between this capacitor and this resistor here, it sets the time delay. So when you click on the switch, factory was like 2 seconds, 2.5 seconds before this relay coil engaged and pulled in the contacts. So I changed this out to, I had it sitting around here. It's a 220 microfarad at 16. So I essentially doubled, or just a little bit more than doubled, the capacitance in that time delay circuit. And let's try it. So with this increased capacity in the circuit here, it's no longer a 2-second time delay. It's about 4 seconds, which actually isn't such a bad thing. It takes a while for this amplifier board to stabilize, and at 4 seconds, it's not unrealistic to try that. And let's see, we should have a junk AM talk radio. Yeah, so that's about 4 seconds. Oh, it just happened again. Oh. All right. Well, that wasn't the solution either. I just don't know what to do at this point. Take those diodes out. I mean, it isn't the end of the world if it just does that once at the startup, and then it works fine. But I'm so aggravated by this. I mean, how many parts can you change before you just, I don't know. So I'm still waiting for capacitors and trim pots for the amplifier board. So I am going to put those parts in when they arrive, and maybe those trimmer pots. Maybe the trimmer pots are just erratic, so erratic that it's, but I doubt it. Why not try it? I lifted these 3 diodes out of the circuit, so if I understand this correctly, there isn't any sensing of current or voltage that's included in the circuit. So this circuit should be nothing more than just the time delay turning on the relay. And yeah, like this. You see that? And then I got the old millivolt meter hooked up here to just monitor our what actually comes out of the amplifier on whatever this channel is, left channel. So here we go. Click it on. Okay, we have AM junk radio.
U.S. women's first match, and I sat close enough to listen to Heather O'Reilly.
So I'm on.
Scream her way around the field. Why are we subbing on corner kicks? Screaming, we have to.
I don't know what that noise was.
Funny. She was so locked into her competitive side. Do you know how to get under her skin? Do you have a plan to?
I wonder if this is a bad thing, doing what I'm doing.
Maybe just a little shoulder to shoulder, show her my strength a little bit, and I need to keep it up too.
But these are millivolts on the output of the amp.
So, we'll see. Maybe a little physicality will get her.
All right, well, I wish you the best. Thank you very much.
It's more than I would have thought it would be.
On Mom, and
thank you very much. I appreciate it. Thanks so much for having me.
You got
shoot.
it.
Let me flip it up, check it again. The offset voltages. This is our DC offset, so we are on auxiliary input. Volume is turned on all the way. We have an 8 ohm load on each of the speaker terminals. So when we click this on, if we clicked it on, the switch would be over here, right there. 4 seconds. So this should be our 0 volts reading. And it's heading that way. That's 4 millivolts. Oh boy. I don't know if you heard that crackle, but that is from this amplifier. There is something going on with this amp, and I don't really know what it is. I've heard that crackle before. Shoot. Something's getting thermally active. That's the regulator. Ooh. Maybe we need to revisit this power supply. Maybe we need to change that regulator. Next to nothing. Maybe it's a transient like that from the power supply that has been the bug all along. I mean, technically we've completely eliminated the protect circuit. You can see those diodes are removed right there. And maybe that transient from the power supply has been tripping it, and until we turned that protect circuit off, we just didn't really know what was going on. Maybe that's it. I have one of those regulators. Let's swap it out. Check the solder again on the back side. All right, I've got this. I've been calling this a regulator, but actually it's a transistor. Got this out of the power supply board and put it in our tester here. And I believe this, so I'll show you. You have got to be kidding me. This thing has been dead all along, and the whole thing worked? That's just unbelievable to me. And remember how I was gushing about the power supply, how clean it was? And I decided not to change the other components because I just thought I was throwing parts at it for no reason. Yep. That's on me. All right, so let's look at the new one. Where did you put it? Where did you put it? The new one. Here it is. Okay, so this is the new one. You wouldn't expect this to be a capacitor, would you? And heavens to Betsy, it's not. It's exactly what it should be. So let's put this back in. I just can't believe it, that this power supply worked. It's just a little intermittent glitch that. So let's... All right, one last test of this. So I've got the leads clipped into the socket and then clipped onto the transistor. See if we get the same thing. Sure do. The leads are in different orders, but yeah. Wow. Okay. Unbelievable. I just am speechless. And I can't believe how ignorant I was. Well, there it is. One component at a time is what we're going to do. Let's turn it on. What do we have here? I think we're on AUX input. Turn it on. 1, 2, 3, 4. We are in AUX, so let's go to AM radio, talk radio.
For the last couple of weeks.
Okay, let's bring up the other speakers here. Okay.
We'll see if there's any fallout with JJ. Obviously, having a
down there,
to this extent,
down there,
a serious offer to another candidate. We'll see if that impacts things.
How in the world did this power supply even work with that in there?
I believe JJ is back to the status as the favorite.
So when you look at JJ Redick, how concerned
I feel really dumb.
are when it comes to JJ with the lack of head coaching experience?
I am going to change the rest of those transistors. This one, and then this other one is also, what is it? Is a 313 or something like that. Unbelievable. We may have gotten it. Yahoo! All right, 2 down. And 2 more to go. Let's try it. Let's see what happens.
Number 1,
all right.
he plays for the Boston Celtics. Yep. Number 2, they
sound.
Want him to be Larry Bird.
Sound.
They want him to be Kevin Garnett.
Sound.
They want him to be Paul Pierce. They want him to be that guy that delivers when it comes to putting the ball in the basket.
Hey, listen, this sports talk is really serious. Very serious. This is looking a little...
impacting the basketball game.
I checked it. I checked this resistor and it seemed to be okay, but... Alright, let's turn this off. Junk radio. 2 more to go. Alright, well, we got all the new parts in. Let's turn it on. And I just plugged it in. Let's see if it works. 1, 2, 3, click.
Last week, and I don't know if you remember this.
AM radio, baby. Alright, so that's great. Everything's working.
I said, Freddie, what would surprise me if JJ Redick got that head coaching job?
You called it.
Because LeBron isn't just doing a podcast with any and everybody, man. Like, y'all got to read between the lines.
All right. Gonna button this back up, or at least get it together enough that I can upright it and maybe drive it for another day just to take a look at it, listen to it, and we can discuss this. All right, well, the Protect board that you've seen 100 times is back in and in order. I replaced these diodes because I had heated them up a number of times, taken them out of circuit, and just decided to replace them. So this board is done, in theory, and the power supply board is looking pretty good now too. So let's turn it on. And we've got our milliamp meter set up here to monitor our whatchamacallit. gonna monitor the whatchamacallit, the DC offset. Where's our switch? 1, 2, 3, 4.
My son knows he should never.
All right.
He never talked to me about his gun.
I keep the gun where she can't.
So we have, these are millivolts.
I don't know where it is.
She does.
We're going to check this in a minute, but
Keep your gun locked away when it's not being carried.
we're just,
Take the time to talk with your kids.
I haven't turned it on yet. This is the first I've had it on since I replaced all the stuff. So I think I finally figured out what was going on. I had really decided that these active components on the board were all fine, and that changing the caps on the power supply board was really all I needed to do, change the relay, and completely ignored this. But I don't know if I'd have found this otherwise. If we had just shotgunned parts, it would have been, yeah, you replace a bunch of parts, but you don't really know what part was the one that was the problem. So maybe it was worth it, because how we got to this point in the end was by lifting those diodes out of the protect board, those 3 diodes, which effectively eliminated any kind of protection on that board. So all it did was have the time delay control of the speaker relay, which you see right down there. So by eliminating the protect circuit from doing anything, we were able to hear that noise, which came from the power supply. It was just a pop and a crackle from the speaker intermittently. And when I just brushed my finger against it, I could hear it again. It was just would have been too much of a coincidence if my finger brushing against it wasn't demonstrating the problem. So that's how we found it. Was, call it scientific, call it dumb luck, I don't know, but it's been on for 5 minutes and the relay hasn't tripped. The DC offset is looking okay. Maybe we'll just take a little peek at it again, maybe. Did I go the wrong way, maybe? Let's see. Yeah, probably. Let's go this way. This control is super touchy, as we mentioned, and that's why we're going to replace it. So, we did all right. I'm going to let it run for a while, and I'll check back. Well, today's the day to change the capacitors and the trimmer pots on the amplifier board. Schematic. So we're going to do that. It really shouldn't be a big deal. Caps and trimmer pots, caps. Already did the transistors. And the amp works fine, so why are we doing this if the amp works fine? I don't know, maybe I learned my lesson, maybe not, but I think ultimately these trimmer pots really needed to be replaced. They're really sensitive, and why not change the capacitors? So, I'm going to get at that now. I'm going to tip it on its side, and I'll show you. Well, we got the amplifier board recapacitated. That worked out really well. Nice capacitors or Nichicons. And these are the 4 things we have left to do. These trimmer pots. May not be quite as easy to get them out as a guy would want. They really did use a lot of solder. And I have not cleaned the board up yet. So I haven't thrown power to it yet. But I just squirted some deoxide in here, and it looks like there's some corrosion on some of these wire wraps, and I'm going to be very gentle. I did touch up some of these stakes in here, but I just wanted to kind of just give the wires a little bit of a clockwise tug, gently, these wire wrap connections can be, well, they're very positive and they seem to hold up very well, but you still have to take a look at them. And yes, I nicked some of these wires. Just looking at the stakes, some solder joints, solder. Yeah. Yeah. Because those connections go to the output transistors, the big bad boys. There really isn't a good way to get at them, and I don't want to make a mess out of it if I can't. So turn it on. We should have AM junk radio coming out. Wish us luck.
America's #1 sports book.
Both speakers, AM junk radio.
This Major League Baseball season with FanDuel, because with Dinger Tuesdays, you can turn dingers.
All right, pretty good. You know, and I do like that 4-second time delay. It seems perfectly appropriate. So these are the caps that came out. Pretty simple stuff, but I don't know if I mentioned this before, but when they solder these, hey, let's turn this down. Turn it off. When they solder components down to the board, a lot of these wires are bent over and pushed against the trace on purpose, I suppose, because it really does make a huge solder connection, but makes it really difficult to get them off. You have to be very careful not to. You got to kind of use your soldering iron almost as like a little pry device. It's inappropriate, but it's the only way, really. And I'll clean this stuff up. Some of it isn't as bad as it looks. Yeah, this might be hard to see, but these are the tabs from the trimmer pots, and they are actually very thick. And when they put them in, before they solder them, they bend them over right down to the trace. And you have to get in with your soldering iron. You need 2 hands. You have to first of all get the solder off. I've been using solder braid. And then you heat up the solder with your soldering iron. At the same time, you take one of these guys. But you have to make sure that the pin is already separated from the solder on the trace before you do this, because you will absolutely pull the trace off of the board. And I've done that a couple of times. Really have to be careful. This is where the damage happens to these circuit boards most of the time. And you don't want to force it. So that one, okay, so I'm going to get back in it, heat it up, soldering iron, and see if I can coax it out now that the pins look fairly straight. I'm going to try not to move the position of the pot so that I can read the resistance setting on it before I put the new one in, and I'll preset the new one roughly to where it should be. So, yep, one must be cautious with this kind of work. And then we're going to definitely clean the whole board up with all this, get out as much of this rosin off as we can. So, okay. Well, needless to say, you have to be very careful of the orientation when you take this trim pot out. And you can see on the on this layout of the foil, you might have to go in there and really pay attention to where's right there, where's my finger? Right there. Where the wiper is. It's hard to see, but the wiper is on the same piece of trace that one end of the resistive element is. So the wiper's there, and these are the either end of the resistive element. And in this particular case, that's the wiper, resistive element, other end of the resistive element. So, super importante. And I see 51 ohms. Let me show you this. $51 ohms. I would assume it has to be kind of, well, first of all, let's just confirm it's a 100 ohm pot. Well, almost. 51 ohms. And $34 ohms. 51 ohms. Okay, I'm just clipped in here, and this is the way it is out of the box. So that's basically right in the middle of the pot control. So across the resistive element, it's 103 ohms. So it's right in the middle, and you know, this the old one is setting. The setting is pretty much in the middle. I'm going to leave this. I'm not going to make any pre-adjustment on this one. I'm just going to pop it in, put it in, and it's not so far off that we can't adjust it once it's up and running. I just wanted to make sure it wasn't wacky, you know. Moving on. Well, I've got the first trimmer pot in, and I have it on right now, so I got to be careful, but despite my best efforts of trying to keep the trace clean, I still broke it right there. And it's okay. It's making a fine connection. But just to show you that sometimes some of these components are really, really difficult to get off. So that's it there. We're monitoring the idle current across the two appropriate pins. And I've adjusted it down. You can see here that it's about 21 millivolts, and they say to let it run for about 10 minutes to settle in. I'm going to just make a little, I'm going to just quit while I'm ahead here, but just to make a drop it in adjustment. And it feels like these new trimmer pots are going to be much more stable. We're talking millivolts, eensy-weensy voltages here, so yeah, we'll see. It's hard. So okay, so I'm gonna just shut it down. Just wanted to show you that. That's just the first one of three, and there's 3 more to go. So I'll do the other pot on the right channel. That one is like a 10K, I think. And then we'll check that DC offset voltage, make sure that that works too. But yeah, this is probably one of the more difficult tasks, aside from when you put in the new transistors. You got to make sure the leads are in the right place, because they're different. A lot of them are different, and these trimmer pots are difficult to get out. And actually the leads coming out of the pot and the holes on the circuit board, of course, don't line up. So you really have to do a little, you know. All right, this is the 10K pot, and I'm presetting it for what I read on this one. So that's about right. 4.5 is what it is. I just wanted to throw one more word of caution out here, and I have been as careful as I possibly can be. And I really did a number on this trace. Now it's going to clean up all right, and the connection is going to be all right, but getting these trim pots out, I don't know if it's worth it. I really don't. In fact, you can just see as an example how this board was built to not really be serviced in a way. They bend the leads over all the way to the trace, makes it a super positive connection. But you get some of these bigger leads that are thick, and it's really difficult to get them out. Now this the leads on this trimmer pot are super thick, and maybe I should have left it. So, but it's too late. I'm in it now. I think this is the best way to get at the bottom of this amplifier board. First, just to desolder these trimmer pots. And I'm just doing some damage, and I don't like it. So I came up with this little groovy move. You get the solder up as much as you can with the solder braid and pry up just a tiny bit of this tab. And if you can get the solder braid underneath, you can heat it up again and get the residual underneath the tab. So the tab is now free from the trace. And I did that over here. Because, I mean, getting these trim pots out is probably the hardest thing. I mean, getting some of these transistors that have heavier leads out was also a booger, but I didn't destroy it. I could always make a little bridge across this point, but it's a fine connection. And I was just horsing around with the adjustments on this channel, the right channel that I did, and I don't know if these trim pots, these new ones, are really making much of a difference in terms of the sensitivity of the adjustment. So I don't know. I might just say leave those old trim pots alone. I mean, there is just, diminishing returns sometimes when you really get in and you start changing a lot of components. And I consider myself to be a pretty good solderer, and I'm really struggling with this. And tipping the receiver on its side and doing sort of the limbo dance, trying to get at it in goofy angles, is really not where you want to be. You want to be in the best possible physical position to work the soldering iron and pay attention to stuff. So yeah, I kind of wish I had just put it on its bottom like this, top actually like this, and get at the bottom this way. So, okay, I'm going to get these two trimmers out and finish this task, and then we'll turn it on. I know it's going to work, but yeah, kind of a bummer here. And also here, I found a broken trace also, so I had to do that. This board has really been worked, and I'm the worker on it. Yeah, rebuilding these things, I don't know. You got to decide what the risk-reward is in doing so. Well, I managed to get the second pair out much cleaner. And in fact, the pots are still hanging in there. I just have to tip it over and they should pull right out. But these are your best friends doing this kind of stuff. The solder braid, the super tweezers, the super long nose, needle nose pliers, and the eensy weensy screwdriver. And you just have to really get in there with the solder braid and just sort of work it. You have to be so gentle not to put upward pressure on these traces. So the board cleaned up okay. Of the broken traces that I soldered around, it's going to be fine. But for heaven's sakes, I mean, I nicked these wires. I mean, this is really not an easy thing to do, to be quite honest with you, getting these amplifier boards redone. It might be worth taking the whole damn thing out and getting it on the bench. Just, snip the wires off and take the whole thing out, make a note of where the wires go, and solder them back onto these stakes when you're done. That might be the best way to do this. I don't know. This is really not easy. So, okay, I'm going to finish this stuff. Presetting the pot, pre-bending, presetting. This is where it was at, approximately 35.5 ohms. So we're gonna go with this, get that one in, then go to the last one. All right, I think this concludes this particular aspect of the job. The 4 trimmer pots are in. I got our probe clipped to pin 3, which is the DC offset. And we should adjust this for 0 volts. So let's go to our meter. Millivolts. It's not turned on yet. Let's turn this. Let's see. We're going to go AUX. No volume. Click and Z. Okay, good. And I did preset it, so it should be fairly close. We should be able to go to this pot. Nope. This pot. Let's see. Let's just VR3. This is VR3. We should have 0 volts here. That's not going very well at this point. Oh boy. Let me check this. Well, I guess it's falling into place now. This is the idle current adjustment. We are between pins 1 and 2. And that's our idle current adjustment pot, the new one. And it's fallen pretty close to where it should be. And let's go back and check our DC offset. So the DC offset, we get one of our probes gets grounded and the other one goes to pin 3. And the other pot works that. So yeah, we want to be as close to 0 as possible. I mean, we're talking millivolts, so maybe we just leave this the way it is for now. Let's check the other channel and see how that works. But this is looking great. I still don't know if I recommend changing these trim pots. This was a bear to get those out with that, and I did some damage. Risk return. So I wanted to show you some of these old transistors that I took out. Some of these just literally don't age very well and they're recommended to be replaced. But you'll notice that almost all of these transistors have this corrosion on the leads, this black in color corrosion. And that absolutely does not mean that these are bad components. In fact, just about everyone here did work fine. But occasionally you'll get one of these transistors and this black corrosion will penetrate up into the case and get to the PN junction, and that'll destroy the usefulness of the transistor, and that's where you get the noise or just it failing completely eventually. So it probably isn't a bad idea to replace the transistors in anything like this. These rebuild kits have the transistors in there as well. Because I think that's what you're trying to avoid, is the inevitability of one of them or several of them failing or getting noisy. Well, I'm not trying to make you envious, but I've been driving this pretty hard for the last hour trying to find something that doesn't work right. And this sure is awesome. So I paired this receiver with these beautiful Advents of the day. And this is also a Pioneer 8-track player. And I got some great 8-tracks. It's an old Jimmy Buffett from about the same vintage as this receiver. Some Super Tramp. Some Knack. Get the Knack. Some Tom Petty. This is one of my faves. In fact, these are all pretty much my faves. Some UFO. These are 2 great UFO albums. Lights Out and Obsession. I gotta tell you, this thing is working fantastic. I am so happy with it, and I cannot explain what I'm about to tell you, but I really believe that with this, with the new caps and the power supply, this thing seems to have much more bass punch to it. So, believe it or not, I don't know. I'm not one of these audiophiles that would describe this in notes of chocolate or lavender. This is just a good old-fashioned vintage receiver that's well built, and it sounds great. And if you've never really spent time listening to 8-tracks, you're missing something, because 8-tracks are awesome. So that's my report on the old vintage Pioneer SX-737. I hope you get one yourself, because you will not be disappointed. Thanks for watching.